Hi, physics. Mr. Janowski here. This is the next part. I think this is part 5 of the chapter 6 and 7 slides. So, do now question: what do we do with ugly vectors? So, if we're looking at this free body diagram, some of them are up, some of them are down, one of them is left. And then you've got f sub a going up and to the right. That's the ugly vector. When you have an ugly vector, you want to do a step 0. You want to find the components. So, in this case, you would take that ugly vector, take it aside, do a step 0, find the components, find out how much of f sub a is in the x direction, how much of it is in the y direction, and then you go back and you redraw your free body diagram, but this time with only pretty vectors. So the difference between this guy here on the right and this guy here on the left is the purple guy is now gone, and instead of that ugly purple guy, I've replaced it with its pretty components. So I have f sub a x going this way, and I have f sub a y going this way. So now, a new kind of problem. 2D force problems with friction on an angle. So we've got Denise, whose mass is 60 kilograms, is going skiing on a hill with a 35-degree incline. So we're not on level ground anymore because, it's skiing. The coefficient of kinetic friction between her skis and the snow is 0.15. How fast will she accelerate downhill? Now, I've already made a video. This problem is actually homework 5, problem 3. So I've already made a video showing you in detail how to do that. But I also have in the slides, I'll just kind of talk through conceptually. That video is kind of long. Hopefully I can at least give you the concept kind of quickly here. So think, what force is pulling Denise down the hill? Meaning like this way, down the hill, the way in which she is skiing. And that, of course, is gravity. Now, what force pulls Denise into the hill? Which means, why isn't Denise flying off into space? What is holding her to the hill? That force is also gravity. Now, which way does this force point? Does it point down the hill or does it point into the hill? The answer is actually neither. This force points straight down towards the center of the Earth. So that's that force. Now, if that is the force due to gravity, which way is Denise going to accelerate? Is she going to accelerate straight down, or does she accelerate straight to the right horizontally? And the answer, of course, is neither. She doesn't go flying off the hill in this direction. She doesn't go flying straight down towards the Earth. She accelerates along the hill. So that makes this thing a little bit weird. In what direction is the normal force? Okay, well, normal means perpendicular. So the normal force in this case is the perpendicular force between the ground and Denise, her skis in this case. And that is, well, it's perpendicular out of the hill. So it's up and to the right in this direction. And in what direction is the force of kinetic friction? Well, Denise is moving along the hill this way, so down and to the right. Friction opposes motion, so the force of kinetic friction must be in that direction, like up and to the left, back along the hill that way. So the easiest way to do this problem is to rotate your coordinate system. So x is no longer straight to the right, y is no longer straight up. What you're going to do is you're going to rotate it a little bit so that it matches the hill. So the new x direction is, down and to the right along the hill. The new y direction is perpendicular to that, which means, perpendicular out of the hill like that. Which seems weird because I would bet that in your entire life so far, x means to the right and y means straight up. And now suddenly I'm telling you don't do it that way. But that is what I'm telling you. Don't do it that way. So the key idea here is, as long as the x and y axes are perpendicular to each other, they're still going to be at a right angle here. Math is happy. Math is going to work. That's the only thing that math needs. They have to be perpendicular to each other. So in our new coordinate system, our step 2 free body diagram would look like this. So yeah, I'm kind of mixing in free body diagram, step 2 and step 1 sketch together, but yeah, it works. So in our new free body diagram, f sub n is pretty, f sub k is pretty, and f sub g is the ugly vector. So how do you find the ugly vector? What do you do with the ugly vector? You do a step 0 to find f sub g's beautiful components, f sub gx and f sub gy. So when you're doing these problems, it is very important to draw your triangles accurately. This 35-degree angle, 35 is less than 45. So make sure you draw it so that it is clearly less than 45 degrees. After you've done that, you draw f sub g straight down. If you've drawn this one correctly, you've got a chance to draw this triangle and be able to see that this angle in here, this theta in here, is the same as this theta down here. If you don't draw it correctly, you're not going to be able to tell, which angle is the 35 degrees. Is it this guy here or is it this guy here? So critically important to do that correct. So yeah, anyhow, you do that step. You do a step 0, you find the components, and then from there, you do a new step 2 with only pretty components. And when I say pretty, I mean pretty according to our new rotated coordinate system. So you do that. The rest of it is straightforward. Do the y side, do the x side. So if you do all this stuff, yeah, I'll tell you what, just go to the other video I posted up there. I did out the same stuff, slower and in more detail. So hopefully you found this helpful.